Okay, so just raise your hand when you're ready. Okay, so let me now give you two basic facts about the quantifiers that are absolutely essential for understanding how to use the quantifiers when you do proofs. Remember that that's the universal quantifier, and this says everything has the property f. So the universal quantifier says everything. The x is the name of the domain of objects, the set of things that that quantifier ranges over. When I say everything, I'm talking about some set of objects, everything in that set. And that x tells me what they are. This x refers back to that x. So all things in the domain x are such that each one, it has f. So here's the basic fact, 1, about quantifiers. This is about the universal quantifier. This is equivalent to the following. All of the objects in this domain, we can give them names. A, B, C, D. Remember, these are names, these are properties. So this says A has F, B has F, C has F. Notice when you say everything has F, that's equivalent to saying A has F and B has F and C has F and D has F, and so on. You just enumerate every object in that domain, and what you have is a big conjunction. So this big conjunction is equivalent to this sentence that says everything has F. Because if everything has F, then A has F and B has F and C has F. That's easy. So that's the basic fact. The second basic fact is about the existential quantifier. Remember, this says something in the domain X, something in the universe X, is such that it has F. Do you know what object it is or what objects there are that have F? No. All you know when this is true is that something has it. So this is how you have to write. This is what this is equivalent to. A has F, or B has F, or C has F, or D has F. Since you don't know what objects have F when you say there is some object that has F, then you have a big disjunction. A has F, or B has F, or C has F, or D has F, and so on. These are the two basic facts. When you know these facts, you'll know everything you need to know about how to use these quantifiers in doing proofs. And let me show you how you can understand using the universal quantifier in proofs when you understand that this is the same as that. So suppose I have a quantifier, a quantified expression. For all x, x is such that if it has F, then it has G. Well, in my proof, I would like to do modus ponens, but I can't because the quantifier has larger scope than the horseshoe. And as you know, you can't do modus ponens unless the horseshoe has larger scope. So we have to get rid of these quantifiers. We have to drop them. How do we do that? Well, to understand why we can drop a quantifier, look at this and this. Since this is equivalent to that, and this is a big conjunction, I can simplify out any one of these pieces. So I could do the following if I wanted to. Suppose I want to show GB validly follows from these two premises. Then I would drop these quantifiers and replace X in both cases by B. Notice, I can do universal instantiation. That's the inference rule that tells me how I get rid of a universal quantifier. And what justifies it is the fact that that and that are equivalent. Since FB is part of this big conjunction, I can simplify that out. So when I drop a universal quantifier, I can replace my x's by the name of any object whatsoever in the universe over which these quantifiers range. So I can replace x by b. And now I can do MP because that has largest scope to get my answer. Universal instantiation is very easy to use. I can replace when I want to drop this quantifier, I can replace x by the name of any object in the universe. If I don't want to replace the variable by a name, I can keep it as a variable. I can do that. I can change the name of the variable if I want. And so on. What this tells me is UI is very easy to use, and I can do a lot of things with it. I can replace my x's by the names of objects, or I can keep x as an x, or change the variable from x to y or x to z. Okay.